arcs, semicircles. So if we can kind of wrap this into one big concept here. All right, so we talked about the first thing. Let's see. So the first part of this, it was like, can you figure out the arc measurement for each piece? You remember doing this yesterday a little bit? Because this is kind of one of the main things that you have to do first before you can do the second step today. So what are we thinking here? Is there a thought process to be had? But I may have drawn a bad picture, so. Yeah. Okay, so half of it has to equal 180. So here's my question, like, is this half a circle, or is this half a circle, or is it this one? You know, did you see me draw it? I'll make it very clear that this, it'll be pretty obvious. That's where half of a circle is. So as I move this way, like,
that's 150.
So all of these two arcs should add up to how much?
180.
180. So this one's 150. So if you look at it, is this half a circle? No, because 40 plus 150 is 190. So it looks like it is, but not necessarily. So is there any way to solve for anything up here?
No.
So I'll give you another angle. So this one's because 20 plus 120 plus 40 is 180, right? All right, that was kind of half of the conversation yesterday, solving for arc lengths or arc measurements. Sorry, I said the wrong word. And then I asked you guys, like, name a minor arc. Arc BK. Is that what you said? Is arc BK less than 180?
Yeah.
Okay. Can you name a major arc?
BKS.
One more time, Josiah. ASE. So that would go from here through S to E. That would be, how big is that arc? 200 degrees? Did I add those up right?
Yes.
20 plus 30 plus 150 is 200. All right, and then the last one was, can you name a semicircle on there? BKE. Does BKE add up to 180? Perfect. All right, so that was kind of all the stuff we talked about yesterday, and then I might throw in today that this line is 5 centimeters.
Did you mean to put bakes?
No, I didn't want to put Baker. That's just confusing.
Yeah, that's.
All right, so if that line is 5 centimeters, can you calculate the circumference of the circle?
Yes.
What's circumference?
Depends.
C equals 2 pi r. And what is the radius of this circle?
Alright, the centimeters is very important.
So the actual circumference is 10 pi centimeters. Alright, so here's the big conversation today. Today we're not going to do arc measure. Today we're going to do arc length.
I think let's say arc measure.
We're not doing arc measure, we're doing arc length. Does that resonate with anybody?
No, so we would take 2 arcs and
So what is perimeter of a circle? Circumference. So if I could try to make this easy, if I asked you guys to find the arc length of BSE. No, the arc measure is 180. Right, you're correct with that. The measure in degrees is 180 degrees, aka half the circle. What is the whole perimeter? 10 pi. What's half of 10 pi? So the arc length would be half the circumference. So the big issue today is understanding the vocabulary. Arc length versus arc measure. What we're going to do today is part over whole equals part over whole. Okay, and the biggest issue is going to be that pi today. So the book says that this is the correct formula to use. So if I gave you a circle, could you calculate arc length with that? Let's try it. Let's see what happens. 6 centimeters, and that's 90 degrees. So the expectation is that you see this formula and you can calculate the arc length of that piece of the circle. So could you stumble your way through filling out those pieces of the circle? Okay, so then what is this thing?
Measurement of AB. Also the arc of AB.
The measurement of arc AB. I'm asking you what that is. 90 degrees. So that is this angle measure right here. And what does that go over? Times 2 pi like, what do you do with that? Calculator won't do it. Because the answers have to have a pi in it. You see how that could be nasty? So I have my method, and I would really prefer to use my method. My method today, I have to, create some space. I really want you guys to write this down. It's a proportion, and we just got done working with a boatload of proportions in topic 9, didn't we? So when you have a proportion, you should be able to cross multiply and solve. So I'll present to you the same question. And we're trying to solve for the arc length of AB. When I say the arc length of AB, that should signify that I'm looking for the distance, a numerical distance from A to B. I don't care about degrees, I care about how long is it. Like a numerical answer. So as we fill this stuff out, what is the length from A to B? We don't know that. What do we call that in geometry? X. That will generally be where your variable is. Then it says circumference, the circumference of that circle. So you have to calculate circumference in your head or write down the formula for circumference under the X. 2 pi r. Wait, if you can jump to 12 pi, that's fine. Equals, right? The arc measure of what we're trying to calculate, 90 degrees, over, that will never change. So if I look at this, if you can understand what you're writing, this is part of the circumference over the whole circumference. Does that make sense? Part over whole. This is part of the circle over the entire circle. Part over whole equals part over whole. But how do you solve that? Cross multiply. So before you solve it, I recommend simplify first.
So that'll be
Simplify, then cross multiply. So can I simplify x?
No.
Can I simplify 2 times pi times 6? What is that? Can I simplify 90 over 360? You may not be able to, but who can? The calculator. So go over there and simplify, control divide 90 over 360. Oh, thank you. 1 over 4. That takes the stress away from the cross multiplication, doesn't it? 1 times 12 pi? 12 pi. X times 4? 4x. How do you get x by itself? Divide both sides by 4. 12 divided by 4 is 3 with a pi next to it. The pi is what really screws people up. 12 pi over 4 your calculator will not simplify that. It says it's 9.42. But we did in our head the simplification process and got the same answer. Does that kind of make sense? So if you can't simplify 12 pi over 4, you can always calculate 12 over 4 and go back and add your pi in there later. Right, so all of this class, the majority of this class lies in the fact that you can remember how to operate with this formula. So it's populate, simplify, then cross multiply. And we're just going to leave it here and try and do this. So it says, what is the length of the darkened arc? So if you can't see it, I'll highlight it for you. What is the length of the darkened arc? We're trying to find out how many meters is that yellow chunk of the circle. So do you remember the formula? Arc length,
What we're trying to figure out, which is so we just put x.
x, over, so this is the length of the piece that we want, over the length of the entire circle, aka
60.
circumference, 2 pi r. Does that make sense? So the length of the yellow arc over the length around the entire circle. The measure of the highlighted arc. How many degrees is the yellow arc?
60.
300. That's the trap most people fall for, because it's the darkened arc. This piece is 60. The whole circle is 360, so 360 minus 60 is, the yellow arc is 300 degrees. Again, a portion of what we learned yesterday. And then how many degrees is the whole circle?
360.
360. So we have a length over a length and a degree over a degree. Simplify before you solve. So instead of saying x over 2 pi 15, call that 30 pi's. If you can't simplify 300 over 360 in your head, the calculator will do it for you. 5 over 6. At this point, we're going to cross multiply and solve. We'll go the easy way first. 6 times x. The more complicated way next, 5 times 30 pi's. So 5 times 30 is 150 with a pi next to it. Solving for x. Can you simplify that? The calculator can, if you type it in correctly. Do I need to put a pi in there?
No.
So control divide. Uh-oh. Control divide 150 over 6. 25. 25 what though? Now the answer is 25 pi. How do you feel about that? The only way to check your work is to type in what you were simplifying and type in the answer you got to see if it makes sense. And it's a lot of extra work, but it pays dividends in the long run. 150 pi over 6 is 78-ish, and we got the answer 25 pi. Those are the same answer. So you can calculate the equivalency there. So what's the hard part of this process? The formula, the simplification, the solving. Remembering it, right? This is not on your formula chart. It will be in your notes for the quiz on Friday, won't it? Hopefully it will be. So if there's anything on your notes, that's kind of been a problem lately. So we're looking for the arc length of VT. So you have to know, what does arc VT look like? How many degrees is arc VT in order to solve this process? This arc is 150, and please describe how you found that. Those two pieces on the left half of that circle have to add up to 180. So who can populate the formula? Oh, you're right, Luke. 2 pi r, and r in this case is 5. So that is a length over a length equals degrees over degrees. Does anybody prefer to just go ahead and cross multiply there? Or do you guys like to simplify step first? You can. You want to see what it looks like if I skip simplify?
Yeah.
Okay. If I skip simplify, you get 1,500 pi. That's 10 times 150 pi equals 360 x. Then divide both sides by 360. Then you have to simplify this. So we have to simplify, but we're simplifying at the end. So in the calculator, most people don't like doing this. It's 1,500 over 360, and it spits out 25 over 6. So it's 25 over 6, then where does the pi go? On the top. So the answer is 25 pi over 6. That is the length of that purple arc. If you simplify from the beginning, you get 5 over 12. The simplification process doesn't look as nasty. So just cut both those numbers in half. Because I simplified 150 over 360 to 5 over 12.
That makes no sense. Say 12, 6 is 5, 12,
50 pi.
There you go.
When you do the math right
And it'll look pretty.
right? So either way, those two answers are the same. You can simplify from the beginning or you can simplify at the end. Alright, this one's been giving us a lot of trouble today. Arc UV. So we just found out that this was 150, right? We calculated that last time. How big is this one?
90.
So how big is arc UV?
I don't have that much space.
240?
No, wait,
120?
which way?
That's something you should know.
It would be 90 because it's a 90 degree, and then you add those
It
30
has
to that 90,
Yeah.
so it would be 120.
Well, we have two people with two different responses. Is it this one?
No, you always
It's
get the
not-
smaller,
it's
it's a minor.
And how did you know it's a small baby
Because it only
arc?
has 2.
Because there's only two letters. When there's only two letters, it's
Oh,
the
where's that
shortest
at?
distance.
I didn't say it there.
Right? That's the issue. Right? People will do the right kind of math, but for the wrong arc.
So the other one is 240.
So this one is 240, but this piece is only 120.
Okay, next question.
So
X 2.
how do I know it's already this 10 pi? It's the same example from the last one, so I can automatically cheat and simplify because I know the circumference is 10 pi. Equals the arc that I want, 120 over the arc, the whole circle that I have, 360. Now if you simplify at the beginning, this time it spits out some pretty nice numbers.
If you divide it by 12, it's pretty.
Like one.
Yeah, 1
If you divide by 120, it's even nicer.
That's what I was
So cross multiply 1 times 10 pi,
thinking.
x times 3. Divide both sides by 3. And arc UV is 10 pi over 3. Or like 3.3333 pi. Still doesn't make any sense, does it? So the distance all the way around that circle is 31.4. And then we're saying that the distance from B to U is 10.4. Does that make that like 1/3 relationship stick a little bit? Does that help that kind of stick? No. Let's try another one. So UTV,
That means you go to major, so U.
U to T to V.
So you know where you're going. Definitely.
That's
This one's 240.
Right now, if you divide them by, to 120, you get 1. Wait, no, 2.
So the length of the arc that we want
You already
over
know
the
what's
length
the
of the
10
arc that we have.
And it's 240 over 360. And if you can simplify.
So that's something you can simplify. So this arc is now Did we have to do that? How big is the entire circle? What's the distance all the way around the circle?
Oh, sorry,
Distance around the circle. Huh?
Are you there? Are you there?
Miss Baker. Yeah. Thank you. Sam, you're going home or down to the front office. The distance all the way around the circle is what?
10, because it's a little.
10 pies. Well, what if I just subtract? Wouldn't that give me the other half of the circle, the other chunk of the circle? So 30 pi over 3 minus 10 pi over 3 is 20 pi over 3. No. There does also exist stuff that looks like this.
That's cool.
Is it that bad? How many degrees are in a circle? 360. So this arc and this arc and this arc all add up to how many degrees? 360.
And now you just simplify that.
Right, so like you take a concept you're not readily familiar with and you apply old school concepts to it, it's not really that
You
bad.
just add the common denominator.
Right?
So 10x, and then maybe. Now you subtract 80.
X equals 28.
We're not done yet.
Well, if I can do that in my head, 28 times 5, 140,
That one on the calculator.
90, and then 140 minus 10, 130. What was that up to 360? Alright, so,
We're not.
what's
We
that?
have to do all this stuff.
No, that's it. You're done. You don't have to do any arc length or anything like that because there is no radius in that triangle or that circle to compete with. So the goal tomorrow, right? Today we were doing this.
That's not Professor Williams'
We were saying how long is this arc? Tomorrow we're gonna say what is the area
of this.
of that sector. So it is the same exact formula. We just changed one little piece. Same kind of math. Tomorrow is kind of a half day.
Or the last one?
I would like for you guys to do where it says circles day 2, the back of this, right? So be careful, be careful, be careful. What is that 18 represent on number 2? That's the diameter. So the circumference of that circle would be 18 pi. You can cut it in half, 2 pi 9, you get 18 pi. Remember pi d is also a thing. Down here in the bottom, you're not finding arc length. You're just finding the measurement of each arc, right? So how big is each arc? So it's like a couple questions, nothing too terrible. We have about 15 minutes. Definitely something you can finish today in class. I'm picking this up tomorrow as a homework grade. I'll probably pick it up and then give it right back to you so you can use it for your quiz on Friday. So the more work you do now in your notes and on that assignment, the more stuff you have to draw from for your quiz on Friday. So I'll give you 15 minutes of time to work on this.